Yeah. Okay. Yeah. Thanks for that. Anyway, so we're going to deal a lot with this particular question. Okay. I see someone asking about the attendance in the chat again. So that's the last time I'll put that out there one more time. At this point, you should be here by now. Okay. All right. So again, we're going to talk more about this meaning of phase in a minute, because as we're going to see, and you're going to use this all the time in 2112, you know, as I said last time, the sinusoid, the sine wave, is really critical in engineering problems. We find it in power, we find it in audio, we find it in radio, right? It's all over the place. And one of the things that we find out about it is when you're analyzing problems where you have sinusoidal waveforms, it turns out you don't need to keep this whole expression, all right? You actually can simplify this whole expression significantly, all right? And you can do so using complex numbers, which at first sounds odd. You basically are using some imaginary number to make something simpler, right? That sounds weird, but it turns out that that's actually true. It's conceptually more challenging, but it's actually, from a process perspective, a lot simpler. And we'll get into the reasons why we do that. But this idea, for now, all we're asking you to understand here is basically just what a sinusoidal function of time looks like. And it has these three parameters: the amplitude here, the frequency, and the phase shift. Okay? We'll have a lot more to say about that later. All right, now I'm going to get into this a little bit, but how did I plot this guy in MATLAB? That's really kind of the next thing we're going to talk about a little bit. But you can see that the waveform has the parameters that we just worked through there. Okay, we'll come back to that picture. What I want to do in particular is I want to get into this question of, here real quick, MATLAB. Okay. The question here is, MATLAB is what I would call an interpreted language. Okay. And so I guess I have written out there what that is. Maybe I shouldn't have written out there, but an interpreted language, what that means is that you don't have a compiler to worry about. Okay. So that doesn't necessarily mean a whole lot to you, but you should have a good sense of this about what a compiler means, right? In C, you guys took C or C++ or whatever it is, right? And essentially there, what you did is you wrote your code, you put it through a compiler, and then you got some executable that you ran. In MATLAB, you don't do that. You write code and you run the code, all right? And there's an interpreter that executes that code in real time. That makes things simpler in some ways, but as I wrote here, and we're going to look at an example here today, the downside to that is that bad things can more easily happen. Okay, bad things can more easily happen. We're going to get into what I mean by that. All right. In MATLAB, what we do is we write scripts. All right, and that's what you do in any kind of interpreted language, is you write scripts, which are basically just a series of commands. All right, so I've got MATLAB here. Now, someone asked the question last time, what version of MATLAB should I download? I am running on this machine 2020B right now, or sorry, 2018B, right? You should download the newest version. I will do my stuff in a version that's behind the newest, so that I know that whatever I post will always work for you, right? You will see that my MATLAB window probably looks, in fact, I know that it looks different than it does for you out of the box. All right, I basically take my MATLAB down so that I just have the command window. All right, and so I can write commands at the command window here, okay? Now, what I typically recommend that you do is if you want to start working in MATLAB, you click the new script link here, all right? And then I can start writing scripts. And what I can do is I can write whatever commands I want, and then I can execute them by right-clicking, by basically choosing some code. So I can highlight some code, I can right-click it, and I can say evaluate selection, and it'll run that code, okay? That's the simplest thing to do, is always write stuff. One of the biggest differences between MATLAB versus your calculator, in your calculator, you run one line at a time. And if you want to run that line again because you screw everything up, you have to go up, 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 and go back to it. If you write the stuff down like this, you don't have to ever recover it. You can always just kind of look to see, well, if I made a mistake in my code somewhere, let me fix it and then go back to using it. All right. We're talking more about this idea of scripts, but basically what you write is scripts, and those scripts always end with a .m extension. Okay. All right. So we're going to play with some scripts here today. All right. So some big differences between MATLAB and C. MATLAB is very similar to C. Its structure is very similar. The good thing about it is that it's got no pointers or memory management, all the stuff that you kind of learned about there in C. The way that I think about this, as it says here, if you think C is easier than MATLAB, and you might right now because you've never used MATLAB, but if in a week or two from now you still think that C is easier than MATLAB, I've failed you, because it's not. If the way that I think of this is MATLAB is basically got all kinds of built-in functions, and it can basically do whatever you want. All right, whatever you could possibly want to do, MATLAB can do it. You may not know the command for it, but MATLAB can do it. All right. In C, you basically have to create your functions from scratch. All right. Whereas MATLAB has all kinds of functionality built into it. All right. I always kind of compare it in a way to saying, if I told you to build a house, right, you could start by going out into the woods with an axe and chopping down trees, right? That's C, right? In my mind, as you do that. MATLAB is like hopping in the car and driving to Home Depot to buy the parts, right? MATLAB's got everything that you need. You may not know what you need, right? You may not know what the function is, but it's there, okay? And we just got to figure out what that is. All right. So we're going to look at some examples, right? But I want to talk about some really basic concepts in code, all right, because they're really key. The first concept is you always have to clear your variables at the start of any script. You always have to reset your variables at the start of any script, okay? In MATLAB, there's a function called clear, all right? And if I want to learn more about functions, right, I've got some ways to find out some more about functions, or even to look for them. So one thing, you know, if we just go to a Google window here and I do a search and I say clear MATLAB variables, right, that just comes up right away. So I see, what you should see is anytime you do a Google search like that, you'll always come up with links from www.mathworks.com. Okay. MathWorks is the maker of MATLAB. All right. And so I always go to their stuff as my recommendation. Right. And usually you don't even need to go directly to the MathWorks website. You just put it into Google. Enough people have already searched it before that the algorithms in Google should get you right to the right spot. All right. So clear removes items from the workspace, all right, freeing up system memory. So clear removes the variables entirely, all right. The alternative, you know, so I say it's always important. This is a basic concept. This is not a MATLAB concept. So MATLAB has a function called clear, which apparently just gets rid of the variables, right? If I was talking about in C, what would I do at the beginning of a program in C to make sure that my variables are cleared appropriately?
Initialize 0.
Initialize it, right? So set it to 0 is sort of the typical thing to do, or set it to the right dimensions and all that sort of stuff. Okay. Other thing is in MATLAB, lines of code can or cannot end with a semicolon. They don't have to end with a semicolon, right? In C, right, you had to have that. The compiler basically just burps and says, hey, I won't do anything because you don't have a semicolon. Because it's not a compiled language, it's an interpreted language, you don't have to have the semicolon, but you can, all right? If you have it, then no output is displayed. If you don't have it, output is displayed, okay? So as an example of that, let me go into MATLAB here real quick, and I'll go to my command window so you can see it down here at the bottom. So let me write this, x equals 2 plus 2. If I don't put the semicolon in there, it says x equals 4. If I do it again and I say x equals 2 plus 2 with the semicolon, I don't see anything. All right. If I want to know what x is, I can just type it and it'll tell me x equals 4. All right. Now that the reason I point that out is because if you write a big script, okay, you may find that if you haven't used the semicolon, let's say x was had 10,000 entries, right? I'd have to wait for all 10,000 of those entries to scroll by. Like, I'm just going to give a quick example. I'm going to say x equals, and we haven't talked about this yet, but I'm going to say it equals this, right? So all of those entries come onto the screen, right? And that can significantly slow down your code. If I had 1 million entries in this thing, it would take a long time for all those things to sort of go out across the screen. So that's one thing to bear in mind. And that leads me to my next point, which we're going to deal with here in a second. Code is always right, okay? So we've got computer engineers and electrical engineers. Problem with building circuits. Circuits might look good, but they may not work. All right. You could have somebody build a circuit and then somebody standing next to that person could fart and that circuit might not work right. All right. Just because the wind blew that circuit around in some way. Hardware is very finicky and it could be built correctly and not work correctly. All right. For various different reasons. Code always works. Okay. As long as the syntax of the code is right, the code will always do whatever it says. So when people tell me my code doesn't work, I'll always tell you that's not right. Your code does work. It's just not doing what you told. It's not doing what you intended it to do. Right? In other words, the code's right. You're wrong. Your logic was set up wrong. Okay. The downside to this basically is that, and again, I'll give you some examples of what I mean by that. But essentially, what it means is you always have to think before you execute your code. All right, in MATLAB, because you can easily make your computer crash because you haven't thought about what it is that you've asked it to do. It works, but it just doesn't work in the way that you thought it was going to work. Okay, and some of you guys might be familiar with this, but this is a really key concept for computer engineers, especially if you're doing embedded systems design. What I've seen happen many times is somebody's built a piece of hardware and somebody forgot to initialize a variable in their embedded code, and then all of a sudden the whole system blows apart. Okay, and you run into all kinds of problems that come along with that. Okay. All right. So I'm gonna to get to some specific examples that go along with that. All right. So before I move any further, any questions about the basic stuff?
You have one question in the chat.
I do. A little off topic on there, but software packages. So when you install MATLAB, you get options for additional packages. You shouldn't need to have any of the other ones than the ones it defaults to, which I think should be MATLAB and Simulink are the ones that it defaults to. You can always add other stuff if need be later. All right, if you install all of the packages in MATLAB, it's probably 100 gigabytes. So you feel free to add them if you want, but you don't need to. All right. Any other questions for now? Okay. All right. So I want to get into some basics of what we think about the terminology that we use. So MATLAB stands for Matrix Laboratory is what it means. And so it's based around the concept of vectors and matrices. All right. So a vector is a single column or a single row, and a matrix is a multi-column or multi-row thing. So we're going to look at an example here. All right, so I will post this script as well. All right, so what I did, this script is the script I'm going to use here in class right now. What I did was I created two vectors here, and so one thing in MATLAB, these are comments here. So if I write the %sign, the % sign creates a comment. So what I've got here is I've created what I call a row vector and a column vector, okay? So let's take those two guys and I'm gonna paste them into my MATLAB window here. Let me move them. I'm gonna move these two guys side by side here. All right, so I pasted those into my command window. So because I put semicolons after them, nothing displayed. But let me type in here. Oops, what I meant to do. X and Y. All right. So let's see. So X basically wrote itself out as a row. I saw entries 1, 2, 3. Y wrote itself out as a column 4, 5, 6. Now notice how I did that. All right. The difference between these two guys here is that I wrote a semicolon after each of the numbers. Right. So 4, 5, 6 with a semicolon gave me a column vector, and X written out with just the entries like that gives me a what I call a row vector, okay? Now, I can turn any row vector into a column vector using something I call in linear algebra a transpose, right? Which is to say that if I type X prime, Y prime like this, what that does is it transposes them. So let's try that. So if I do X, Y prime, notice what happens. X now becomes a column vector, and Y becomes a row vector, okay? So I can flip-flop stuff, all right? Now, we'll talk about this a little bit more, but this concept's really important because everything you do in MATLAB really kind of comes down to understanding that basic relationship. Now, what I also did here was I defined a matrix, all right? So A equals 1, 2, 3, semicolon 4, 5, 6, semicolon 7, 8, 9. Okay. So let me ask you guys this. What's that going to look like, do you think?
It's a 3 by 3 matrix.
It's a 3 by 3 matrix. And what's the first row of that 3 by 3 matrix?
1, 2, 3.
1, 2, 3, right? What would the first column be?
1, 4, 7.
1, 4, 7, right? So I take that guy, I'll paste them in, right? And then I'll say it didn't display because I have a semicolon. And if I just write A, we can see that it's got the form that we say. Okay. All right. So this idea is important. If you've taken linear algebra, then you've probably already seen this. The book has a chapter on linear algebra. I'm not going to talk about that linear algebra very much. Today is the day I'm going to talk about linear algebra. It might come up from time to time. I think it's a sort of a boring subject in general. It's one of the easier subjects probably. For all the electricals, I know you guys are required to take it. I'm not sure if the computers are required to take it or not.
Yeah.
You are?
We are, unfortunately.
Unfortunately. Hopefully it's an easy class, I think. I don't know. Maybe you guys disagree with me. Yeah.
Oh, yeah, it is.
It's a really important class. As you find out, we'll get to this a little bit. I meant to throw in an example today, but I didn't. But we're going to see that example a little bit more. I showed you the radio stuff last time, right, as kind of a motivating example, and we're going to use that in some of our projects later. But matrix multiplication, matrix algebra is really the way that most computer algorithms really function, because you can come up with fast ways to compute when you go into matrix formulations of problems. Okay, so it's really powerful to know and to understand. So in linear algebra, the basic use of it really is to be able to solve simultaneous equations. Okay. And I have a note here. You can look at this, right? I'm not going to cover this subject in a lot of great detail. Like I said, chapter 5's got some, but you got a class, right, that's on this. So it's not going to take too much time on it. But just to make sure that we're all on the same page, let me go to full screen. Okay. So I took an example here where I've got a system of linear equations, and I think, you know, Dr. Yawu will use this quite often in 2112, is, you know, if I said, okay, figure out the currents in this circuit here and figure out those currents using the mesh method, right? If I went through and I wrote my KVL equations for each of these meshes, right, I would end up with these equations. This isn't a circuits class, so we're not going to solve for that, all right? There is a problem on the homework where I'm basically going to ask you to set up some equations and do the same sort of thing here, just as a way to get used to MATLAB, right? But essentially what I'm doing is I've got that set of equations. I can take this set of simultaneous linear equations and I can put it into matrix form, okay? And that form is written out as AX equals B, all right? So a couple of things about that statement. Anytime I got a matrix, I write it as uppercase. Anytime I have a vector, I write it as lowercase, okay? So I have AX equals B. So somehow I should be able to write that, this set of equations in that form, all right? So we're gonna do that. So let's take the first equation here. So 10,000 I1 minus 0 I2 minus 6,000 I3 equals -6, okay? So I'm going to try to put this thing into matrix form, okay? So hopefully I'm going to make it big enough. All right, so I'm going to write it like this. I'm going to say I've got I1, I2, and I3, which are my unknown values, okay? This is my X. This is equal to -6, 6, and 0, like that, okay? All right, so if you guys who know this can help me out with this. So what are the entries in the first row of this matrix?
10,000.
Yep, 10,000. What's in the middle?
0.
0 and -6,000. Okay. And so if you look at this, so what that tells me is if I want to figure out, I should be able to get from this matrix setup here into essentially what amounts to an equation, right? So if I take this row, okay, here, and I multiply it by this column, right, I will get this entry, okay? So 10,000 times I1 plus 0 times I2 minus 6,000 times I3 is equal to -6, okay? And if I do the next row, 0 times I1 plus 12,000 times I2 minus 3,000 times I3 is equal to 6, all right? Or in the last row here, -6,000, oops, -6,000 times I1 minus 3,000 times I2 plus 21,000 times I3 is equal to 0, right? Those ultimately are my three equations. Now to solve this, right? So I guess maybe I should say this is my A, this is my B. So I now have it in this form, AX equals B. So when I write matrices like this, right? So a matrix multiplied by a vector like this, I basically go along this row, then along this column, right? Then I go along this row and along that column and along this row and this column, right? Actually, I don't know that you guys saw this. So I go this row times this column is this entry. Middle row times this column is the middle entry. Bottom row times this entry is 0. Okay. All right. So that's our way of looking at these problems. Now the question then is, the thing I don't know is X, okay, which is the currents here. So I'll ask somebody who's done this in linear algebra, well, what do I do next? What if I want to figure out what my X's are here?
You have to start setting it up so you can solve.
And how would I set that up to solve?
You'd multiply by the inverse of the first matrix,
Yep.
both sides.
So yeah, so if I have AX equals B, if I multiply both sides by what's called the inverse of A, right, I would solve for X. So basically what I end up finding from that is A inverse times B is equal to X, all right? Now I don't want to get into the details. If you take linear algebra, it'll tell you how to do that, okay? And linear algebra will tell you 27,000 different ways to figure out A inverse, right? I'm not too concerned about that. What I'm going to do is I'm going to go into MATLAB and I'm going to say inverse, INV. Now, somebody put in the chat to me privately previously that if I want to know how a MATLAB command works, I can use help, and I can, all right? But I want to say, let's say I didn't know how to make a MATLAB inverse, right? So I want to say inverse, so MATLAB inverse, right? First thing that comes up, matrix inverse, y equals inverse x. Okay, well, so now I know how to do it, okay? Now, the reason, so if I wanted to know how that guy worked, I could write help INV, and it comes up with, okay, inverse of x is the matrix inverse. The reason I go to Google for that is because where you guys are starting at is you don't even know what to ask help for at this point. All right. Typically, if you know enough to put in the right Google search terms, you'll get to essentially what amounts to the same information directly from the web. All right. So that's a really key point. But you can always type help and then the name of the command to get it as well. So what I did, so for this particular set of equations here, again, I'll give you guys this file. I wrote it out here. All right, so notice how I entered it, right? I did 10,000, 0, negative 6,000, then I did a colon, right? And then I did the next row, and then I did a colon, and I did the next row. One thing I guess I didn't point out previously is I also put these things in square brackets, all right? They're not parentheses, right, that I put. Parentheses are used for commands. So notice when I have inverse of A here, parentheses are used by that function, that command inverse, right? When we go into MATLAB, we write all of our stuff into square brackets, not squiggly brackets, not parentheses, but square brackets like that, all right? And then I did my B vector, right? So I did -6 colon, -6 semicolon, 6 semicolon 0, right? And then when I wanted to solve it, I said x equals inverse A times B. So if I want to see how that works, highlight it, evaluate selection, and it pasted it in. I didn't see it, but I can type X and I can see my values. All right, so here's a question. This guy looks kind of funny. Notice what he did. He wrote 10 to the minus 3. So e to the minus 3, right, means 10 to the minus 3 times these values. Okay, so if I wanted to figure out specifically, well, what is I2? All right, I can kind of see it there, right? But let's say I wanted to know just what is that value. So how would anybody know how I would get maybe that value? The middle value here? Just that value?
Is there like an X sub number to identify the index?
Well, there is. So in this case, if it's I can write, so I know that X is, I can say, well, let me do it this way. I'm gonna say X of 2, all right? X of 2, the second entry is this guy. If I want to get the third entry, I write X of 3, like that. Okay. So I can directly index into that guy by saying I want X of something. So kind of like what you do in C. All right. One difference between C and MATLAB is the first entry is X of 1. There is no X of 0 entry, right? Array indices must be positive integers. Okay, so MATLAB always indexes everything from 1. So if you're used to C, that'll be a little bit frustrating for you, right? C always starts at 0, but MATLAB starts at 1. Okay. Now, that's an important concept. All right, but before I get too far into this, we're covering a lot of ground here today, right? There's all kinds of stuff you can do with linear algebra, and there's all kinds of things you learn in linear algebra about how to compute the inverse and how to do all sorts of stuff like that. I'm not going to talk about how I compute the inverse, right? I'm just going to say I can go into MATLAB and I can ask it to make the inverse for me, right? And we use matrix algebra, linear algebra, to basically simplify the solution of simultaneous linear equations like this, okay? And that's one of the most common ways of using linear algebra. All right. I don't have a whole lot more to say about that, right? I think the key things that we've learned so far, just to kind of summarize real quick, is we've learned some key concepts here in MATLAB, all right, which is to say I've learned about vectors and matrices, okay? And I have learned about how to set up a system of simultaneous equations, okay, in this kind of format, which is really important, all right? Now, I mentioned previously, you know, so some basic concepts here, all right? I mentioned previously some issues that you can run into with MATLAB, all right? So a couple of important concepts. I talk about a matrix A, all right? So any matrix I call A has a size m by n, meaning that that matrix has m rows and n columns, okay? And a vector is either m by 1 or 1 by n. All right, so let me ask you guys this. I talked about row vectors and column vectors. A vector that's m by 1, is that a row vector or a column vector?
That's a row vector.
Guess again.
Is it a column vector?
Well, I mean, there are two options.
Yeah, exactly, right?
It's-
So I say it's a column vector because it's tricky, right? What it says is it has m rows and 1 column. So if I thought about something that had m rows and 1 column, right, I would have something that was like this. And the first entry might be this, the second entry would be this, third entry would be this, all the way down to the mth entry, like that. All right. So that would be, it's confusing because it's got the row number in here, but this is a column vector. Okay. That's, you know, that's not the kind of thing that's kind of trivia in a way, right? But it's important to kind of understand that. So I write in here, how do I check the size of something in MATLAB? Like, let's say, for instance, a project comes up and I give you a file. All right. And I will do that. You'll do some audio processing probably in one of the projects, and I'll give you a file, and you'll have to load a value into MATLAB, and it'll just be called X. Okay. All right. What you need to do always probably is you want to, I gave this idea there at the beginning about you always want to verify what it is that you're doing and think about what you're doing before you just ask MATLAB to do it. All right. Classic example of this, you may come across the same problem, but last year, project number 1 gave a project, had a problem I thought was cool. The students ultimately liked it, but they just exploded initially, the first couple ones that did it, because their computers would all crash when they'd do this. And the thing was, again, their code was correct. All right, we had this whole big argument, it wasn't working. Well, no, it was working. It's just you hadn't thought about what it was that it was going to do. One thing to do is if I use the size command tells me what the size of a vector is, all right? And if I want to know so I typed size of X, it told me 3, 1. And if I wanted to know what that means, I can type help size, right? It tells me a lot of stuff, right? But it basically says for an m by n matrix, X returns the 2-element row vector D equals m comma n. So what it tells me is that for any matrix X, the first entry of this output is the number of rows, and the second entry is the number of columns, right? So what it told me, I didn't mean to get rid of that, is that if I type size X, not size Z, I don't know what that is, size X, right? Size of X, I have 3 rows and 1 column, all right? So I can type X like this. Now for something that's only got 3 entries, right, I could probably just look at it and know that as well. But if I give you something that, you know, has thousands of entries, it's not easy. You can't look at that all at once, right? And so that size command is really helpful to be able to see that, all right? So similarly, if I do size of A, right, I see that A has 3 rows and 3 columns, okay? That may seem trivial to you right now, but I'll give you an example of this later where it becomes non-trivial pretty quickly, okay? All right, so got about 20 minutes left here. Any questions so far?
What caused their computers to explode? You mentioned that they crashed.
They crashed. Yeah. I'll get into the specifics of that example here a little bit, right at the end of class, probably.
Thank you.
Fundamentally, I'll say this. Fundamentally, what caused their systems to crash was they didn't think about what the code was going to do before they executed it. Right. That's why, you know, I live by that mantra of code always works, because it does. Right. And you really have to think about, have I written the code that solves the problem I think I was trying to solve? Right. And it becomes important to think it through and not just write the code and see what it does, because it can have some consequences. I've seen it have really pretty nasty consequences when you're doing embedded design, at least. Anyway, so that's something that you won't fully appreciate until you've caused that problem for yourself at some point. Anyway, so a couple of things, you know, I'm going to highlight here. Again, going to Google is really important, because you may have an idea. Well, I want to do something in MATLAB, so let me Google that a little bit to try to figure out what to do. Here's a couple of useful commands. All right, ones, zeros, linspace, and log space. All right, and what they do. So a matrix of ones, a matrix of zeros, a matrix of linearly separated points, and a matrix of logarithmically separated points. Okay. And it may not seem obvious to you right away that some of these things are useful. They will become useful as we go. All right. We're going to be doing MATLAB baby steps probably in homework number 1, where we start with some simple stuff to begin with, and then we're going to expand it out as you get more comfortable. But our first step is to get comfortable with it. All right, MATLAB has everything that C would have, in the sense of you've got for loops and while loops and do loops and all that kind of stuff. So there's a lot of things that it can do. It's just really specialized to being able to handle numerical simulation, which is what we'll see. Okay. Now, in addition, and I guess one of the things I say is MATLAB has a component to it called Simulink. I talked about that. I used the term earlier. All right. We will utilize Simulink a little bit throughout the semester. Simulink is a simulation tool. It's really powerful, because what it can allow you to do is, like last time we talked about a robot, right? I can actually do the mathematical design with the equations and stuff in MATLAB, get it to do what I want it to do, and then potentially have Simulink, after I've simulated that system mathematically, have it create code that'll go into a microcontroller. All right, so I can do some automatic code generation and things like that. So MATLAB and Simulink are really, really, really key as development tools, particularly for embedded system designers. Okay, and we'll see a little bit of that as we go through the semester, right? All right. One of the key things for us here today, and the thing that I really want to kind of end up on a little bit, is a really key thing in MATLAB is to generate plots. So like here, right? I generated this plot in MATLAB, and what I did was I wrote a piece of code like this that generated this plot for me in MATLAB. All right. So what I wanted it to do, and let me take it to full screen. What I wanted to do was to plot this guy right here, x of t equals x sub m cosine omega t plus phi, right? And I had all those parameters that I wanted to have in it. All right, so we're going to look at what I did to do that. So what I did was I said, well, this guy has a period which is 0.1 seconds. So I wrote capital T equals 1 over 10, right? And I put a semicolon after it. So I've defined the period. Now what I did was I created a time vector, all right, a time vector. And this is a really key concept as well, right? So this is, in terms of basic concepts, we're learning a lot of basic concepts in this video or this lecture that for you to use. So this really key concept here, right, is how do I create a time vector? So in this case, what I said is I have a time vector t that starts at 0, okay, and ends at 2 times t, okay? And I have steps between those points of t over 1,000. Okay. So what that means is what? You guys tell me. So if I looked at t, first of all, what do you think t looks like? Starts with 0. What do you think the next entry in t is going to be?
And 1/1000th.
Yep, it's going to be at whatever a capital T is divided by 1,000. What do you think the next one's going to be?
2/1000ths.
Yep, yeah, 2 times T over 1,000. And the next one will be 3T over 1,000. And it's going to continue like that all the way up to 2 times T. And as I've written that guy right there, is that a row vector or a column vector?
Visually, you've written it as a row vector.
Yes, I have. And MATLAB, if I have these colons like this, will make it a row vector. Okay. Now, what I did was then I defined x. And really, this is kind of x of t, right? But I've written it as x, but it's a function of time. So I said x is equal to 10 times cosine 2 times pi times this guy right here, right? So if I look at this, 2 pi times 1 over t times this vector t plus pi over 4, okay? So one thing that is really important for me to probably point out to you as well right now is that all the trig functions, sine, cosine, all of them, if in MATLAB, they are defined to be in radians. Okay, and so that means that because that is the definition of sine and cosine, they are defined in terms of radians. So I can't put degrees in there, but there are, again, if you Google around, you'll find essentially that there is there's a radian to degree function and there's a degrees to radian function. But unlike your calculator, right, there is no way to take MATLAB from degree mode to radian mode. It doesn't do that. All right, you have to, every time you enter it, think about what it is that you're entering. All right, that's really an important point. Okay, now Luis, I see in the chat, asked a great question. Why is it t over 1,000? All right, it is because I chose it to be, and that's the only reason. Right, but that's a good choice. Okay, and that's a great question, because if I wanted to see this waveform here, right? So I chose to visualize this guy. I chose to make a time vector that had steps of a period over 1,000. So what this means is how many, let me ask you the question this way. How many points do I have in one period of this waveform? All right, how many values are there in one period of X? Can you guys tell from that?
2,000.
Roughly, yeah, it might be 1,001. I think it should be. It's basically 1,000 points in one period. All right, and that, I know that if I do that, then my sine wave is going to look pretty when I plot it. Okay, and we got to define what that means, right? But basically, I chose let's choose 1,000 points in a period. This point is really important later on, and I wanted to introduce it a little bit today. So, Luis, that's a good question. So figure one here. So what did I do to plot this guy? All right, and you're gonna have some plotting that you're gonna do in homework one. But what I have here is I wrote figure one. So what that does in MATLAB, if I write that, it opens up a figure called figure one. If I wrote figure 100, it would open up a window called figure 100. All right, and then I write plot t comma x. So what it's gonna do when I do that is it's gonna plot the time vector on the x-axis, and it's going to plot x on the y-axis. All right, and then I added some stuff here that isn't all that important, but I said grid on, x label, y label. So I labeled my axes. All right, section 3.2 of the book talks about that stuff. All right, and I'll point you to that in the homework. All right, but it's helpful at understanding this concept a little bit. Okay, so I've got a plot that's drawn out here. Right, and I want to get to that point that Luis talked about a little bit, right, or that he asked that question about. Jump over here. All right, so I'm gonna really introduce something really quickly here. All right. If I gave you the signal x of t, and x of t was equal to 10 cosine 2 pi, well, I guess I had, in this case, for that particular signal, it's 20 pi t plus 45 degrees. Okay, let's say I had that function. I want to plot it. That is by definition, what I would call an analog or continuous signal, meaning so any signal we have in the real world, right? When I say in the real world, I mean here in the physical domain that we all live in, everything is analog, which has two meanings to it, right? To be analog, there's two things. One is that it has to be, you have continuous real valued magnitudes, meaning that if I looked at the the y-axis, I can have any number on that y-axis. Similarly, on the time axis, I can have any possible value. So I have a value at time t equal to 1 second, and I have a value at time t equal to 1 nanosecond, right? There's no step from one point to the next. Now, in a computer, obviously, I can't do that, right? If I wanted to draw a plot of x of t, I can't have my t vector. So let me ask you this. How many real numbers are between 0 and 1?
Infinite.
Infinite, right? So I can't say, hey, MATLAB, create a time vector that's infinite, right? That's not going to work. My computer definitely won't like that, right? Because it only has a finite amount of space. So in any kind of computer, we have digital signals, right? And I'm going to skip over digital signals. What we're really going to deal with is what I call discrete time, which is to say that I can have a real number on the y-axis, but my time values can only be at certain points, okay? And that's because I can't plot this particular waveform for all possible time values between 0 and 1 second. I can only choose some. And the question is, how do I make a choice for something like this value here? So the question that was asked in the chat, I chose t over 1,000. I said that gave me 1,000 points in a period. Why 1,000 points in a period? Why not? Let's look at this problem right here. Okay, so I want to plot 10 cosine 20 pi t like this. And I'm going to plot it 3 different ways. So if you look at what I did here, I chose 3 different time vectors. So one time vector that has steps of 1 over 100, one that has 1 over 10, and one that has 1 over 2. Okay, so this has 2 points in a period. This guy has 100 points in a period, right? And then I created x1, x2, and x3, and I plotted them all. All right, I'm not going to deal with this comment I have right here, but if I want to plot them all at once, this is how I would do it. Now, let me ask you this. If I had 100 points in a period versus 2 points in a period, what do you think the difference is going to be when I plot those?
How smooth the line is.
How smooth they are. So I see accuracy in the chat. Yeah, basically, so if it were up to you as the designer of this thing and you were going to plot that stuff, so this, if you think about what x of t is going to look like, so if I run this code, and let me run it real quick. All right, I'm actually just going to run this part of it here real quick first. All right, I don't want it to make the plots just yet. So let's look at x3. Oops, I just screwed everything up. All right, x3, let's look at that here. So x3, which is this guy right here, all right, has values of 10, -10, 10, -10, and 10, all right? Those are basically values that came out of 10 cosine 2 pi t, okay? If you were MATLAB, how would you draw that waveform? What do you think it does?
It probably looks like a staircase.
That's one way to do it. Yeah, it could look like a staircase. What would be one other option? I think I know what you mean. You might mean something different than when I say staircase.
Zigzag.
A zigzag. Yeah. So you would draw a line in between the first 2 points, and then in between the next 2 points, and then in between these points, and then in between these points. So what it does is something called linear interpolation. It draws a line in between all the points that it has. So if I run the rest of this here, I notice that it pulls up figure 1. All right, so notice the window is called figure 1. And the blue waveform is x1. All right, the red waveform is x2. And the yellowy orange one here is x3. All right, so notice all three of them are the same function, right? Which one looks the closest to cosine? Looks like it's x1, right? The blue one, right? So what this tells us is if I want this thing to look correct, I need to be intelligent about that time step, right? There is a whole theory that you will learn later called the Nyquist sampling theorem, which tells you how to choose that value. All right, there's a theoretical way to do it, but it's also relatively intuitive. All right, and it's intuitive based on if I know what the waveform is going to look like, I should be able to make an intelligent choice to make it look like that. All right, so your calculator makes some choices about that kind of stuff when it makes plots. You in MATLAB, you have to make a choice about that yourself. All right, or else you could deceive yourself pretty easily. All right. I usually do like 100 or 1,000 points in a period, okay? All right, so that's the primary thing I wanted to touch on. I did want to really kind of hit on an example, I guess, of what I mean by what happens when you don't think it through, right? Which is to say, what happens if I took something like this, all right? T equals 1, 2, 3, so I created a time vector, but my x values, I have 4, 5, 6, 7, 8, 9, 10, 11, 12. What do you think that's going to do? Anybody want to guess?
Will it kind of look like a scatter plot?
Well, yeah, what it'll end up doing, so if I read help plot, then plot will tell me what it will do. But what it's going to do is it's going to plot 4, 5, 6 versus on the x-axis 1, 2, 3. And then it'll plot 7, 8, 9 versus 1, 2, 3, and 10, 11, 12 versus 1, 2, 3. So if I copy that code and paste that into MATLAB, I get that. I get 3 lines with points at 1, 2, and 3. So this is the thing. This was basically what caused the students' computers to crash last semester. Right? Because I gave them a vector X and I told them, or matrix X, and I told them to make some plots, and they didn't look at the size of it. And because they didn't look at the size of it, what happened in that particular case, there were 200,000 columns and 200,000 rows. So it tried to draw on the screen 200,000 times 200,000 different points. And the computer just, hung and couldn't deal with that. But if you, in that particular case, again, if you thought through what you were being asked, then you would realize, oh, wait a minute, that's not the right way to do it. So the reason this is what I'm saying, code is always correct. Even though you might have only intended to plot 4, 5, and 6 versus 1, 2, and 3, MATLAB doesn't care. If MATLAB's capable of doing all of them and you just asked it to do all of them, it's going to do it, right? And that's the kind of thing where, the code is not working in the sense that it's not doing what you wanted it to do, but it does work. And so it will do something. And what it does in that case, may then cause your computer to crash, right? And again, it's hard to appreciate those things until you've done them. But if you come across some weird issues like that, that may be probably an indication of what you might be doing wrong. Maybe I don't fully appreciate what it is that I've written. Okay. All right. So that's today's stuff. I will post this lecture. I will post the notes from this. But other than that, I am done for today. So I'll hang out here for another 10 minutes or so. But that's all I've got.
When will we be getting our first homework assignment?
So as I said at the beginning, it's coming out tonight.
Do you know when that might be due, that homework?
As I also said at the beginning, in 1 week from when it's posted.
What is the figure parentheses 1 in the code that was just up earlier? What does that do?